everyone, I'm Hannah. I'm a tutor at Sky Academy. We're looking at the topic of measurement, specifically non-right angled trig, MSM6. This is our 8th and our final video in this topic, and we're going to be looking at radial surveys. So a radial survey is used to create a diagram of a piece of land. So it's like a picture of a real life example, and it's shaped in a polygon shape. So it involves drawing different lines, as you can see here, from a point of origin, and it goes out to the corners of the polygon. So let's have a look at some questions. So the first question, it says calculate area using a radial survey. So we have to figure out the area of triangle ABC. So the first thing I'm going to do is have a look and see what triangle is triangle ABC, because we have 3 triangles in here. So here to here is A, B, C. So ABC is the whole big triangle. So I need to find the area of this massive triangle. To do that, I'm going to find the area of this triangle, and this triangle, 1, 2, and 3, and then add them all together to find the area of the whole thing. So let's go ahead and do that. If you remember our area of a triangle for a non-right angle triangle, it is half AB sine C. So I'm going to go and do the first triangle here first. So I need half, area equals half times A times B times sine C. So this 82 is going to be my angle C, and so this here is going to be my side C. So that means I know 5 meters and 7 meters is going to be my A and my B. So 5 times 7 times sine C, or sine 82, and I'm going to put that into my calculator. So 0.5 times 7 times sine 82 gives me an answer of 17.3 to 1 decimal place. Now I'm going to do that same thing for my second triangle. So A equals half. Now I need to figure out where my sine and my sine C is. So it's going to be 136, which means this is side C here, opposite it. And that means 4 along here and 5 along here is going to be my A and my B. So I'm going to do 5 times 4 times sine 136. And I'm going to pop that into my calculator. 5 and 4, and it's going to give me an answer of 6.9 to 1 decimal place. And my third triangle is area equals half times A times B sine C. Sine C is going to be 142, which means side C is going to be here, which means my A and my B is going to be 4 and 7 times 4 times 7 times sine 142, and then I'm going to put that into my calculator. And I get 8.6. Now I'm going to add 17.3 plus 6.9 plus 8.6. Add them all together. To get 32.8 to 1 decimal place. And that would be the area of the radial survey ABC. So essentially all you have to do is find what your angle C is. So my angle C was 82 136 and 142. Once you've got those, you know that the opposite side is going to be side C, and then the leftover two sides are going to be A and B. So let's have a look at another question to do with radial surveys. Here we have a compass radial survey for a field, which means it will have bearings and angles in it. So what is the size of angle POQ? So POQ, so this is the angle I'm trying to find here, theta. If I know that this angle here is 72 in here, 72, because P is 72 degrees true from north, so that's 72 in here. And all across here is 145 degrees true. I can do 145 degrees minus 72 to get the difference between the two, and that will tell me what POQ is. And so 145 minus 72 gives me an answer of 73 degrees. So I know in here is now 73 degrees. What is the size of POR? So now we're trying to find POR, which is in here. So I know that from north to point P is 72 degrees. So now I just need to figure out what north, because I figured out what north to P is. Now I just got to figure out what north to point R is. And if I know that all the way around here is to 290, I know that this gap in here is 360 minus 290. Because we know that a full revolution is 360 degrees. And so if I've almost got a revolution, but I've stopped at 290, I can figure out what the difference between the two are. And that's 70 degrees. And so 70 degrees this way plus 72 degrees this way is going to be 142 degrees all up. And now it says, calculate the length of PQ, this length here, which I'm going to make X. And now we know we can use either our sine rules or our cosine rules to calculate X. However, we only have one angle and two included sides. So I can't use my sine rule. So I'm going to have to use my cosine rule. And that is C squared equals A squared plus B squared minus 2AB cos C. Now I'm going to label my diagram according to A, B, C. And so here is going to be cos C, so that's no longer O, it's going to be C. X is going to be my side C. And that means A and B is going to be these two here. So now I'm going to do C squared is what we're trying to find, so it can stay there. Then I'm trying to do A, so 4.A. It doesn't matter whether you did 4.8 as A or 4.5 as A. Those two are interchangeable. It doesn't matter, but it does matter that you get your C and your cos C correct. Plus 4.5 squared minus bracket 2 times 4.8 times 4.5 bracket times cos 73. I know cos C equals 73 because I worked it out in question A. Bracket. And now I can solve for C squared. So 4.8 squared plus 4.5 squared minus bracket, bracket 2 times 4.8 times 4.5, bracket times cos 73 bracket, bracket equals 30.65954. And then I'm going to square root that to get rid of the 2, the square root of 2. So C equals square root of 30.65, blah, 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 blah. And therefore, C equals 5.54 to 2 decimal places. It was 5.53, but I just rounded up to 5.454 to 2 decimal places. And that's how you do compass radial surveys using trigonometry, such as cosine rule.